Well, that's why we do these tests. This is the cheapest 1/4-inch CNC router bit you can buy on Amazon. And today we're gonna test it out and see what it's capable of. I've also purchased several other cheap bits that we're gonna test out as well and see what they're capable of. Let's get started. The first bit we're gonna test is a $4 bit. Let's see what we got here. I bought several of these. So each one of these should be a 1/4-inch shank with an 1/8-inch cutting diameter. And this is a 3 flute. Looks like there's a hole in the top of it. That's interesting. I've never seen that before. Let's see how sharp this is. A common thing to do is to do a fingernail test. And if it grabs on your fingernail, then you know it's sharp. And this one, although it's peeling a little bit off my fingernail, it's not really grabbing, but we'll compare it to the rest. But that's a good idea to tell how sharp your bits are to start off with. So this is the setup that we got here. Before we run any tests in the CNC, we're gonna take some pictures, take some video underneath the microscope here and to get some before pictures. All right, so this is the $4 bit. So you can see all the machining lines. You can see how kind of rough it is. So I've blown all the dust off this, but there still can be a little bit of like magnetic static charge going on here. So like this right here is a little bit of dust. Moral of the story here is that you can just give us a reference point on what it looks like before we run it. Let's get this chucked up and run our first test. So this first test is gonna be the same for all our bits. And it's just gonna be a profile toolpath that's gonna do a rectangle. The depth that I'm gonna go and the speeds that I'm gonna go are pretty conservative. Again, my goal isn't to break this right away. My goal is to see how it wears. So we're just gonna do one rectangle at an 1/8-inch depth and see what happens. All right, so here is after the first test. Obviously this bit survived, it didn't break. Honestly, I'm not seeing much change in the bit here. You know, no discoloring from heat buildup. Maybe the tip, we'll have to compare that back to the original one, but maybe that tip right there is a little bit rounded off and maybe it wasn't before. But honestly, not much change. Let's move on to the next test and see if we can see more of a difference. So I've got the bit back in the CNC, and test number 2 that we're gonna run all of our bits through is a pocketing test, basically to test durability. So we're looking at like length of carve and how long something can last in this test. So I hit pause on this job real quick. So I've been going for about 11 minutes, pocketing at 90 inches per minute at an 1/8-inch depth of cut. So we're gonna speed it up even more. I'm gonna increase the feed rate and cover a little bit more ground. All right, so my first observation is some discoloring. And let's see if we can see that underneath the microscope. All right, so remember that heat is the #1 enemy of bits. Heat buildup causes dullness and things to dull quicker. So you can see it here. You can see the discoloring. That test that we just ran was 20 minutes long at a fairly different speeds. Now these are all supposed to be made out of tungsten carbide. There's no high-speed steel here. So discoloring, which we know is heat buildup, but that's all we're seeing. All right, so now let's get to like a strength test, and I have a feeling it's going to break. Let's see. This next test is a toolpath that is the hardest on bits in general, and that is a profile toolpath that is a full depth. Now we're gonna take this in 2 passes. So we got a 1/2-inch plywood here. We're gonna take, our depth of cut is gonna be 0.25, so 1/4 of an inch. And the reason this is so hard on these bits is because those chips can't get out because the downcut bit is pushing them down into the cut. And again, if the bit's recutting chips, it builds up heat in this particular toolpath, dulls your bits pretty quickly. And so we're gonna see how long this lasts. I'm anticipating it breaking, but I don't know. All right, so I was right. I figured it would break. Now, I want to put a caveat here because some of you will probably say in the comments that any bit would break. Doesn't even have to be a $4 bit. Any bit would break under these conditions with this toolpath. And yeah, completely get that. But I wanted to test on how far this would go. So I actually made it pretty far though. Heat buildup is what broke this. It wasn't the stress of the IPM, it was just simple heat buildup and made the metal weak and snapped it. All right, so I got it under the microscope here and it's really interesting. So remember we talked about the discoloration before. And you may be tempted to think that this discoloration is from the wood. That is just simply the metal turning a different color because of heat buildup. So something that's really interesting is I actually talked to a metallurgist. That's a new word for me, but it's an expert in metals. And he said something really interesting that I'll share when we test out the cheapest bit and we have a little more context. Basically what we're seeing here, like I said, is the metal heating up and changing colors. And you know, as that happens, the metal gets weaker and weaker and weaker, and that leads to bits breaking. So we're gonna stop the testing of this bit right here, because whether we test it in hardwood, whether we test it in any other material, isn't gonna make a difference. Color changing is the big takeaway here. After 25 minutes of use, let's move on to the second test, or the second bits that we're gonna test. All right, so now we are gonna test the second cheapest bit that I bought, which I bought a 10 pack for $14. So $1.40 a piece is what we come out here. All right, so these are 1/8 inch diameter with an 1/8 inch cutting diameter. Let's see what we've got here. We've got 10 of them. Obviously not as much material, so we're at $1.40 a piece for these 1/8 inch bits. Let's see how sharp they are, the initial test here. So there we go, that's what we were looking for before. See how this grabs and is like, it'll dig in, and I'm putting the same light pressure. So these bits are actually really sharp to start off with. All right, so next we are gonna look at the second cheapest bit here. And you can see that these edges, let's see if I can point it out here. These edges, again, try to get some of this dust off here. But look at this edge, like right here. It comes to a point much better than the first ones. Overall, honestly, the machining just looks much cleaner than the first bit. There's the before picture of the 1/8 inch downcut bit, and we'll see how it holds up. All right, so we've got the second bit we're gonna test loaded up. I had to put an 1/8 inch collet in because this is an 1/8 inch diameter bit. So we did that first test. That is a 1/8 inch depth profile pass. And honestly, it didn't snap in half, first of all. That was the main thing. When you pay $1.40 for something, you really don't know what's gonna happen. So I like to start light. But there is no visible damage, there's no color changing. That's pretty light. So we're just gonna go right on to the second test. All right, so this is the one that'll take a little while. The pockets back and forth. All right, so I went and hit the pause button here real quick. We've been running this for 10 minutes and nothing's really happening. Everything is cutting well. This is a downcut bit, so everything's nice and smooth. The top edge is nice and smooth. And so now we're gonna speed it up. So 10 minutes at 60 inches, we're gonna speed that feed rate up by 25% increments to finish out this pocket, and we'll see where we end up. After this pocket, then we'll take it underneath the microscope and see if we can see anything. All right, so we ran this for over 20 minutes, pocketing at various speeds. We reached over 100 inches per minute with this 1/8 inch bit here. And it's honestly not that hot. So let's take it under the microscope and see what we can see. I can see a huge difference between this one and the first one. There is no discoloration on this second bit. Now again, we paid $1.40 per piece on Amazon for these. I don't see any wear, like visible wear, on this bit at all. Ran it for 20 minutes, no color change. So let's move to the next test. I'm really curious to see if this will survive our next test, which is a 1/4 inch depth of cut, doing 2 passes, cutting all the way through our 1/2 inch plywood. Let's see what happens. Well, that's why we do these tests. It's not even hot. There you go. Cut all the way through in 2 paths. Wow. I'm honestly, like, especially, so this is the same exact speeds and feeds as the first one. They've gone through the same exact test to this point. I'm kind of blown away. So you can see clean top surface here, kind of a rough bottom edge, and that's because it's a downcut bit, so it's pushing all those fibers downward. But at the end of the day, it cut through 1/2 inch plywood in 2 passes at 60 inches per minute, and there's no discoloration. So since we visibly can't see anything, like, it doesn't make sense to put it under the microscope because this is performed very, very well right now. I think we need to do one more test and then put it under the microscope. So our next test is going to be a full depth pass. We took this 1/2 inch plywood in 2 passes. We're going to take it in 1. See what happens. Half inch plywood, full depth cut, 60 inches per minute, 18,000 RPMs. I did ramp in, meaning I gradually went in. I didn't just straight plunge, but that is acceptable. Quality looks fantastic. I'm gonna get the bit out and we can look at it, but honestly, it looks new. All right, so got the bit out here. Let's get under the microscope and see what we can see. So it looks really good. You can see a little bit of browning right there. And that's not the metal turning colors. That is residue, like whether it be wood or plywood glue or something like that. Just kind of a little bit of a buildup on it. But that's normal. But other than that, I mean, you be the judge. Like, I think it looks very, very similar to what we saw at the very first time. All right, before we test the cheapest bit on Amazon, the cheapest 1/4 inch bit that you can buy, I want to give some insight into what we found here, comparing the first bit we tested to the second bit. And specifically, remember I talked about the metallurgist, I think I said that right, metallurgist, what they said that I most likely would find. He said the binder that holds the carbide particle together is what is cheap and will break down quicker. So in Andy's words, all of these bits are carbide, right? You'll see them on every listing, like made out of carbide, tungsten carbide. But that's not a solid piece of carbide. They're made of carbide particles mixed together with a binder that holds it all together. So let's look specifically at these 1/8 inch bits, because I think this proves our point really well. So you can see this is our first test bit. I will note that there is a difference between these in flutes. This one's 3 flute, this one's 2 flute. So that can affect chip load, which can affect heat dispersion. But other than that, I think the main difference between these 2 bits is material makeup, that binder makeup, right? You can even see, just like comparing these together, look at the quality. Now I know we got hot over here, but look at the quality of this metal versus this metal. This looks much shinier. It looks much more like machined. This looks a lot rougher and just unfinished. So obviously we're not going to be able to tell here. We're not going to be able to test the binder makeup. And unfortunately the manufacturer isn't going to list that online either. But with our very unofficial test, I would say this is just a real world test. We can see, running them through the same test, this one turned, got hotter quicker and broke because I believe that binder is less quality. Who knows what it's bound with, right? And then this one surpassed our expectations by far. I did a full depth pass with a $1.39 bit. This one, by the way, this 3 flute was $4. So this was the most expensive bit that I paid for, and so far is way behind this one. All right, so now we're to the cheapest bit you can buy on Amazon. The cheapest 1/4 inch bit you can buy on Amazon. I know the last one was an 1/8 inch, but this one is supposed to be a 1/4, so let's see what it is. The other thing about this is a 3 flute compression bit. This is literally a 1/4 inch coated 3 flute compression bit. I don't know how they did it. So let's test it out and see what happens. So first, let's see how sharp it is. Very sharp. If you can look, it's literally peeling up my, it's like I can't move it across my fingernail, and I just produce, like, look what it's doing to my fingernail. So it is much sharper than all the rest that I've tested here today. So let's get a reference point for the cheapest bit here that we have. You can see the machining here. Also see that there's like a relief carve on it. You see there's, so see if I can point it out. There's the front edge here, the leading edge, and then there's another edge right here, and then there's another one. That's different than all the rest of the bits that we tested. And then there's the compression part. So here is the down cut section, and then the rest of this is the up cut section. But all in all, I mean, I think the machining looks good. I mean, they come to a clean point. This is our reference point to start off with, and then we'll see what happens. All right, so let's test the cheapest router bit I could find on Amazon, $1.20. I paid $1.20 for this. If you don't believe me, look at this screen right here. It says $1.20. Yes, I paid for something for shipping, but that went to USPS. So the person that sent this to me got $1.20, and it came from New York. That was the shipping address, so I don't know, take that for what it's worth. Let's see what happens. Is this thing just gonna fly apart when it goes into the wood, or is it gonna outperform itself like the last bit did? So let's see. All right, so let's take this to the microscope and see. It's hard to see with the blue coating, but I think I can see some stuff that will look better under the microscope. Okay, so that last tool, the first tool path that we did, this first test, was a 1/4 inch depth of cut, 80 inches per minute, 40 IPM ramp. Again, so you can see some of this dust here, which I've been blowing it off. It still is kind of like magnetized to it, but. So you can start to see some of that coating right there, peeling away. And this was after, this was a 30-second tool path. So this is what we're seeing after 30 seconds. Interesting. So let's do, I think we'll be able to see a lot from this next test. We'll do our pocketing test. We'll run it for 10 minutes or so at those same feed rates, and then we'll speed up the feeds and see what happens. So we just did over 200 inches per minute with this bit. It's just crazy. Let's see what we can see under the microscope. So obviously some visible wear again. This is basically more of what we've seen from the first pass. Overall, we ran this bit for 13 minutes at various speeds. We started at 80, increased it all the way to 200. So it's running at 13 minutes straight, pocketing, and you can see the wear. That's our depth right there. That's our max depth. We didn't cut into this area. So you see the coating is just peeling right off, or just getting worn right off. Honestly, I don't give much thought to expensive coated bits or coatings on bits in general. For most things that we're doing, hobbyist and in wood, like there's just no really reason for a coating. But this gives us a good visual of where the wear is. And then you can see the tips here, the teeth at the tips that coating's coming off too. But very interesting. So obviously it's held together. There's no major chips in it. Let's see how sharp this is. See how it's retaining its edge. Yeah, it still grabs, like it's still peeling up my fingernail. It's retaining its edge. That's 13 minutes of use. Obviously not a ton of use, but it's still sharp. All right, we're loaded up and ready to go again. This test, we're gonna go straight to a full depth cut, one pass, plywood. So 1/2 inch depth of cut, 80 inches per minute. Let's see what happens. Yeah, so this is a compression bit, so it should be leaving a clean top surface and a clean bottom surface. It looks like I didn't plunge far enough below or the upcut portion of the bit, because so this is the bottom. It's kind of, that should be smooth. All in all, I mean, that's impressive. So that was 80 inches per minute. I think I could have done faster based on how it was reacting and the chip size here. One final test here. We're gonna see, I put a piece of cherry hardwood up here on the CNC, and we're gonna do a full depth pass on 3/4 inch cherry with this $1.20 bit from Amazon. It passed all the plywood tests with flying colors. I'm assuming it's gonna break in half. It should, but I really don't know. I hope it does, because otherwise we're gonna have a lot to talk about and try to figure this out. Let's see what happens. That is so clean. A lot of heat built up. You can feel the heat in the wood. And that's because we don't have any chip evacuation. It's a deep canyon, so it's recutting the chips, generating a lot of heat, which would lead to, you know, it dulling quicker and breaking. So I'm extremely impressed with this $1.20 bit off Amazon. I'm speechless. So where does this leave us with cheap bits on Amazon? Obviously, there's a lot more expensive bits out there, and there's cheap bits, right? So the whole goal of this was just to test out what you get when you buy the cheapest bits on Amazon. The cheap Amazon bits have a place in your workflow, and I believe the more expensive bits have a place in your workflow. If you hit a clamp, or if you don't get your speeds and feeds right, you're not out much, right? Practice with these, but also new tool paths. If you're unconfident in a new tool path or new material, use a cheap bit. Don't throw your $20 or $30, you know, downcut bit in there and not know what's going to happen. So use your more expensive bits when you take the unknowns out of the equation. So if you are as impressed with this bit as I am, make sure to hit that subscribe button so you can see other videos like this as I release them, and other cheapest tests in the CNC world. I've got a video right here where I talk about the cheapest CNC router, and I've got a video right here where the cheapest CNC laser on Amazon. So check those videos out, and I will see you in the next one. Thanks, bye.